Hi, so for this time we are going to talk about our new topic, which is the theories on differentiation of algebraic functions. And on this time we are going to use the differential formulas for finding the derivatives of a function. We're done with the use of three-step rule, which is the increment method. And we use this to find the derivative of a function. Yes, it gives us the basic procedure of differentiation. However, these rules are laborious and tedious when the functions to be differentiated are complex, that is, functions with large exponents, functions with fractional exponents, and other rational functions. That's why it's very important that we be familiar with the different theorems on differential formulas so that it will be easier for us to get the derivatives of a function. So let's see how can we denote this derivative. We have d over dx. We also have dy over dx, or f prime x. These are one of those familiar notation and when we are finding the derivatives of a function, and this can be also called as the Leibniz notation. And let's move forward. What are those rules of differentiation? We are gonna talk about the basics first. And we have the constant rule, power rule, constant multiple rule, sum rule, product and quotient rule, chain rule, general power rule, derivative of a composite function as well. I will also discuss how to get a derivative of a function given a radical. Now we have our first rule, the constant rule of differentiation. How does it work? So if we have c, I say here, if we have c as a constant and any real number, then the derivative of a constant will be always equals to 0. So let's see the first example that we have here. Say we have the function f of x is equals to 5. The derivative of that constant will be 0. And say we have f of x is equals to 43. As well, the derivative of that will be 0. Say, let's have another example. Say I asked you to find the derivatives of a 3 pi. The answer will be also 0. Why? Because the pi has its equivalent value, which is 3.1416, that we need to multiply to the constant 3. So the product will also be a constant. That's why our derivatives for this is equals to 0 as well. Okay, let's have the other one. Say we need to find the derivatives of square root of 7 or the square root of any constant, any real number. Then the answer will be also 0, or the derivative will be also 0. So make sure you remember that if we have we are going to find any derivatives of any constant, it will always be equals to 0. Now we are in the second rule, which is the power rule. Here, yeah. So if we have n as a positive integer, then here we go, how we can locate for the derivative of a function. In other words, to differentiate a power function, we need to decrease the constant exponent by 1. Here we have n, and then we need to deduct 1 on it. And then we need to multiply the resulting power function by the original exponent. here. The resulting power function, we have x as its base, then multiply to the original exponent n. Let's see the example for this. Say we need to find the derivatives of x squared. So we have 2, and what we're going to do with the power of 2, we'll just have to multiply it to our base x. That's why we have 2x, and then subtract 1 from this exponent 2. So we have 2 minus 1, then the answer will be 2x. And how about for this portion? When we are going to find the derivatives of x raised to negative 4, then we need to use this power negative 4 or the exponent negative 4 to multiply to our base x, and then subtract 1 from negative 4. That's why our derivatives of this function will be negative 4x raised to negative 5. Now we are on our third rule, which is the constant multiple rule. It goes like this. So if f is a differentiable function of x and c is any real number, then cf of x is also differentiable at x with c as a constant or any real number. So in other words, when we are going to get the derivative of this constant times the function x, it will be equals to the constant, which is c, times the derivative of the given function if the derivative exists. Let's see the example that we have. Say we need to find the derivative of f of x is equals to 3x raised to the 8th power. Now, here's what we're going to do, just like what we have in the power rule. On this one, we need to multiply this original exponent 8 to our base x, so that why we have 8x. And then deduct or subtract 1 from the exponent 8. That's why we only have 7. And then multiply it with our constant 3. That's why we have this answer. 3 times 8 is 24. And then just copy this x raised to 7. We have 24x raised to 7 as the derivative of this function. See the other one. Say I ask you to find the derivatives of negative 5x raised to 2/5. So according to the rule, we need to multiply the constant. So the constant will be the negative 5. That's why we have it here. And then get the derivatives of this function. So by the use of the power rule, just multiply this original exponent to our base x. That's why we have 2/5 x, and then subtract 1 from our original exponent 2/5. So 2/5 minus 1 is equals to negative 3/5. And then we need to multiply these two constants. Negative 5 times 2/5 is equals to negative 2. And then we have x raised to negative 3/5. This will be our derivative. Now we are on our fourth rule, which is the sum rule of differentiation. Let's see what's the rule on this. If we have f and x that are both differentiable functions at x, so it means that the derivative of a sum or a difference is equals to the sum or the difference of their derivatives. So we'll just have to get the derivatives of those functions separately. Let's see the example that we have here. Say we have f of x is equals to 7 plus x raised to the 12th power. So according to the rule, we need to get the derivatives of these two functions here, two terms. So get the derivative of 7 and then the derivative of x raised to 12, and then perform the given operation, which is addition. So since we have 7 here and 7 is a constant, so automatically we have the derivative of 7 is equals to 0, and then the derivatives for x raised to 12 using the parallel rule will be 12x raised to 11. So 0 plus 12x raised to 11 is equals to 12x raised to 11. See the other one. Here another example. Say I asked you to find the derivatives of negative 2x squared minus 4x minus 5x raised to 3 halves plus 9. So separately, we need to find the derivatives of these terms. See, first we need to find the derivative of negative 2x squared, and using the constant multiple rule, we can be able to have the answer as well for the second term for x, and then 5x raised to 3 halves, and as well for the derivative of finding the derivative of 9, we need to use the constant rule since we have 9 as a constant. So how does it go? The derivatives of negative 2x squared will be 2x times negative 2. Since here like we have this exponent 2, that's why we multiply it to our base x, we have 2x. Since we only have 2 as an exponent, then when we subtract 1 from it, then we have an exponent 1 here, that's why we have x, and then multiply to our constant, which is negative 2. And then same goes like this. Get the derivative of it. Derivative of x is 1, and then multiply to our constant 4. And how can we get the derivative of this portion? By the use of the constant multiple rule, we have 5 as our constant multiplied to the derivative of x raised to 3 halves. So we need to multiply this 3 halves to our base x. That's why we have 3 half x raised to 3 halves minus 1 is 1 half. And how about in this one? The derivative for finding in the constant 9 will be 0 by the use of our constant rule. And then move forward and perform it. So we have negative 2 times 2x is negative 4x, minus 4 times 1 is 4, minus 5 times 3 halves x raised to 1 half is equals to 15 over 2 x raised to 1 half. So this will be our derivatives, final answer. Now we are going to talk about the fifth rule, which is the product rule. Now that it goes, we can find the derivative of the product of those two functions by finding the derivative of the first function times the second function plus the derivatives of the second function, which is g of x, multiplied to f of x, which is our first function. And let's see the example that we have. Say I have f of x is equals to the quantity x cubed plus 2x plus 5 multiplied by the quantity 3x raised to 7 minus 8x squared plus 1. And then by the use of our rule, then we need to find the derivative first of this first function, and the derivative of x cubed plus 2x plus 5 is 3x squared plus 2. How does it go? So we use the power rule here, and our first term x cubed, the derivative will be 3x squared. We also now use here the constant multiple rule because we have our constant 2 here. So the derivative of x, since we have 1 as our exponent for x, then it will be 1, and then multiplied to 2, we have 2. Since we have 5 as our third term, the derivative for this will be 0. That's why we only have 3x squared plus 2, and then we need to multiply to our second function the quantity 3x to the 7th power minus 8x squared plus 1, and then plus it has been interchanged. It's okay if it has been interchanged because we are looking for the product on this time. So just copy this first function here and then multiply to the derivative of the second function. So derivative of 3x to the 7, we have 21 x raised to the 6th power. And then minus the derivative of 8x squared with the use of our constant multiple rule. 2 times 8 is 16, and then since we have 2 as an exponent, then we only have x here. And then now we have a constant 1, so when we got to find the derivative of this will be equal to 0. That's why we only have 2 terms here, 21 x raised to the 6th power minus 16x. And what will be our answer? Here, when we perform this, we will have this answer 30x raised to 9 plus 48 x raised to 7 plus 105 x raised to 6 minus 40x to the 4th minus 45x squared minus 80x plus 2. Make sure that whenever you are performing these operations, you combine those like terms just like what we have here. So here is just a quick summary. We find the derivative of the first function times the second function. Also, we find the derivative of the second function times the first function. So that's how the product rule goes and work. Now let's move forward to our sixth rule, which is the quotient rule of differentiation. So let's see how the rules goes. And the derivative of a quotient of two functions is the fraction whose numerator is the denominator times, we have the denominator g of x times the derivative of the numerator, we have f of x, and then minus the numerator f of x times the derivative of our denominator, g of x, and then our overall denominator will be the square of the given denominator. That's why we have g of x squared here. Or sometimes we remember it as, say we have this functions. We call the first function as the numerator for the or the function of the numerator as high and the function of the numerator as low. So we have this kind of technique on how to remember the quotient rule. We have low times the derivative of the high minus high times the derivative of the low all over low or low squared, denominator squared, like that. Let's see the example that we have. So you have f of x is equals to 3x plus 5 all over x squared minus 2 And then of course we need to, now for our numerator we have our low, or what we call the denominator first. We have x squared minus 2 times the derivative of our high, or the numerator 3x plus 5. That's why we have 3 here. Minus our numerator, or the high, times the derivative of our low, or the denominator. That's why we have 2x here, because the derivative of x squared minus 2 is 2x, and then all over 2 low, or the denominator squared, which is the quantity x squared minus 2 squared. And yeah, let's perform. We have 3. When we perform this one, then the answer that we can have will be negative 3x squared minus 10x minus 6. We just eliminate those contradicting signs, and as well we combine like terms. And then copy this one for the denominator. Here we have quantity x squared minus 2 raised to 2, or squared. Yeah, the derivative of the numerator and the derivative of the denominator. And this will be our final answer for finding the derivatives. You don't have to perform this denominator because it is on the simplest form already. Now we have the chain rule, so-called chain rule. If we have h of x is equals to g of f of x, then we have h prime x is equals to g prime f of x times f prime x. So it means that the derivative of a composite function using this chain rule, it is equals to the product of their respective derivatives. So let's see the example that we have. Note that h of x is a composite function. Okay, so chain rule applies when we have the composite function. And another version for this is if y is equals to h of x, it will equal to g of u, where u will be our f of x. Then the derivative is equals to the derivative of those the derivative of the product of those respective derivatives that we have here. Now let's see and try to use the chain rule for our example. Say we have our given y is equals to u raised to 5 halves, and the value of u is equals to 7x raised to the 8th power plus 3x squared. So if I use our chain rule, here is our format. Then first thing we need to find is, of course, the derivatives of those two, the derivative of this product. We have derivative of u, or find the derivative of u raised to 5 halves. By the use of our power rule here, we can have the answer, which is 5 halves u raised to 3 halves. Multiply to the derivatives of this value u. We are going to use the sum rule for the differentiation of this one. Then 7x raised to the 8th power, the derivative of that will be 56x raised to the 7th power. Then the derivative of 3x squared is 6x. The next step that we need to do is to input this to our variable u. Okay, it will go like this. we have 5 halves multiplied to 7x raised to the 8 power plus 3x squared raised to 3 halves times 56x raised to the 7th power plus 6x. And then multiply this 5 halves to these terms. There we have 5 halves times 56x raised to the 7 is 140x raised to the 7. 5 halves times 6x is 15x. Multiply to the quantity 7x raised to the 8 plus 3x squared raised to 3 halves. You need to stop on this part because you don't need to perform this. It is on its simplest form already. So this will be our answer for this given example. Now let's see the other rules, because the chain rule also leads to the so-called general power rule. And how does it works out? See, if we have h of x is equals to f of x raised to n should be real number, then we have this as our guide for this rule. The derivative of the power of a function is equals to the power that we have, which is n, times the function raised to the power minus 1, or the exponent minus 1, multiplied or times to the derivative of the function. So that's why we have f prime x here. Example, we have f of x is equals to the square root of 3x squared plus 4x. Then it will be equals to 3x squared plus 4x raised to 1/2 when we convert this radical into the fraction form of our exponent. Then let's see its derivative. So we need to use, since we have the power of 1/2 for our exponent 1/2, we need to multiply it to our given radical. So we have 1/2 times the quantity 3x squared minus 4x. Then subtract 1 from this exponent 1/2. That's why we have negative 1/2 here as our exponent. And multiply to the derivative of this quantity 3x squared plus 4x. The derivative of 3x squared is 6x, and the derivative of 4x is 4. Then it will go like this. We need to multiply this 1/2 to our terms here. So 1/2 times 6x is 3x. 1/2 times 4 is 2. And then since we have the exponent negative here, so we need to make this as our denominator, and then switch it back to our radical sign. Since we have this in our exponent 1/2, then our denominator will be the square root of 3x squared plus 4x. So it means our final answer to find the derivative of this given is 3x plus 2 over the square root of 3x squared plus 4x. Let's try to have another example. So our example, we have to find the derivatives of the quantity 2x cubed plus 4x squared minus 2x raised to 5. Since we have the power of 5 here already, or the exponent 5, what we're going to do next, or the first thing that we need to consider, is this exponent 5, and then put it here, multiply to our given the quantity 2x cubed plus 4x squared minus 2x, and then we need to subtract 1 from the given power, the given exponent. So we have 5 minus 1 multiplied to the derivatives of this whole given function. And let's see. So So we just have 5 times the quantity 2x cubed plus 4x squared minus 2x. 5 minus 1 is 4. And then the derivatives of this function, say we are going to use as well the rule or the sum rule of differentiation. So the derivatives of 2x cubed is 6x squared. The derivatives of 4x squared is 8x, and the derivatives of negative 2x is negative 2. And then we'll just have to perform. We only organize the things here. So we have constant 5 times this one. The quantity is 6x squared plus 8x minus 2. Multiply to this one. 2x cubed plus 4x squared minus 2x raised to 4. It's okay if you will multiply 5 to these 3 terms, but it's okay if you stop it here already, because this answer is already in a lowest term form. So we'll just have to stop on this part, and this will be our final answer. Alright, let's have another example and put some combination for a quotient rule of differentiation. So say we have g of x is equals to the quantity 2x minus 1 all over 3x plus 5 raised to 7. Well, of course, first thing that we need to consider is the power or the exponent 7. So we need to multiply it to our given data here. That's why we have 7 here. And then multiply to the quantity 2x minus 1 all over 3x plus 5 raised to 6. We only have 6 here because we deduct 1 from this exponent 7. And then multiply to the derivatives of the given function here. So what will be the rule, since we have the division here, so we need to use the quotient rule. So we simplify it here, then we get the derivative first of the high times the denominator or the low minus the derivatives of the low, 3x plus 5, times the derivative of the numerator or our high, all over low or denominator squared. So we have 3x plus 5 and then squared. Now let's perform the given. So since we have 7 here, then multiply to 13, we have 91. And then just copy the numerator, 2x minus 1 raised to 6. And then for our denominator, 3x plus 5, we have the same base. So we just have to add the given exponent. Since we have the exponent here 6 and we have 2, that's why we have 8 as our sum for the exponent. Then the derivative final answer will be 91 times the quantity 2x minus 1 raised to 6 all over 3x plus 5 raised to 8. So we'll just have to stop in here on this part because this is in a lowest form now. Alright? Let's move forward to the other theorem. Say we have the composite function as our given. How can we get the derivative of that? So if the function x is differentiable at x, if the function g is differentiable at x and the function f is differentiable at g of x, then the composition function f of x is differentiable at x, and then it goes like, we can denote it as the function of g prime x is equals to f prime g of x times g prime x. So let's see the example so that it will be easier to understand. So we have our given that f of x is equals to x to the 5th power and g of x is equals to x squared plus 3x minus 1. Find the function of x prime x. So first we begin to get the derivative of f of x, which is equals to x raised to the 5th power. Then the derivative of that will be 5x raised to the 4th power using the constant multiple rule. Thus we need to input the g of x to our f of x. So since we got the derivative already, which is 5x to the 4th power, then we have 5 input to the value of x, this g of x, given g of x, and then raised to the 4th power, and it goes like 5 times the quantity x squared plus 3x minus 1. Here, came from here, and then raised to the 4th power. And the next thing that we need to do is to get the derivative of our g of x. So by the use of the power rule, for the first term, x squared, the derivative will be 2x, and for the derivative of 3x, it will be 3. Since we have the constant 1, and then the derivative will be 0. And then just perform and apply the rules of finding the function of x prime x. It will be equals to 5 times our given g of x, which is the quantity x squared plus 3x minus 1 raised to the 4th power multiplied to the derivative of g of x, which is the quantity 2x plus 3. So we need to stop on this, and this will be our final answer. Now let's see this another theorem that you can use when solving for the derivative of a function. If we have f is equals to f of t and y is equals to g of t, there are parametric equations. The derivative of y with respect to x is equal to the quotient of the derivative of y with respect to t divided by the derivative of x with respect to t. Because the format looks like this. Let's see the example. Say we have our example, we have the value here, x is equals to 2t squared minus 4t, and y is equals to 4t minus 2. So find its derivatives. Well, of course, first thing that we need to do is to get the derivative of the value of x. So we have 2t squared minus 4t. By the use of our constant multiple rule, when we get the derivative of 2t squared, we have the answer 4t. And when we get the derivative of negative 4t, we have negative 4. And next step, from the given y, which is equals to 4t minus 2, we got the derivative which is equals to 4. And take a look with our format. It is equals to the quotient of the derivative of y with respect to t all over the derivative of x with respect to t. So we have the derivative of y here, which is 4. So we got it as a numerator all over our derivative for our x in terms of t. That's why we have 4t minus 4 here. And just simplify. So we have 4 over 4 times the quantity t minus 1, and then cancel these two constant. The final answer will be 1 over the quantity t minus 1. Now let's have this one, the second to the last theorem, I think. If the variable x is a function of y, then the derivative dy over dx, or its derivative, is equal to the reciprocal of the derivative of the given function with respect to y. So, and then we can denote it as like this. dy over dx is equals to 1 over its reciprocal. Alright, so let's see the illustrative example that we have. So here we have our given x is equals to 3y cubed. So find its derivative. If we have the given variable x and function x with its variable y, solution. First, from our x is equals to 3y cubed, we need to get the derivative of that. So the derivative of 3y cubed by the use of the constant multiple rule is 9y squared. And then from the x is equals to 3y cubed, we'll get the value of y is equals to the cube root of 9x over 3. So, miss, where did you get that? Where did you get the y is equals to the cube root of 9x all over 3? So we get that from this x is equals to 3y cubed. We'll just find the value of y in terms of x. So let me show you how. Say we have x is equals to 3y cubed. And then first step is to divide both sides by 3. So we can eliminate this. And then we have the answer x over 3 is equals to y cubed. Since we have the exponent in our y, we need to get the cube root of this, both of the equation. Then we can cancel this, and the y will be equals to the cube root of x over 3. And we will not stop on that. Next step what we need to do is, alright, so since we have radical in our denominator, we need to rationalize this. Then we need to multiply it to the cube root of 9 here over cube root of, it's cube root, not 3 squared of 9. It's cube root of 9 all over cube root of 9. So we need to multiply those two for you to be able to understand it. Say it will look like cube root of x times, say, over the cube root of 3. I just separate this, then multiply to this. Yan. Just like that one, multiply to that one so that we can rationalize it. See? And then perform this one, multiply it, and on the numerator we will have cube root of 9x. And then in our denominator, 3 times 9 is 27, so it will be cube root of 27. And what is the cube root of 27? That's why we have it like the value of y is equals to the cube root of 9x all over 3, because the cube root of 27 is 3 here. That's how we get the value of y in terms of x. Alright, so let's continue since you already know where this x is equals to 3y cubed. Where this y value came from. This x is equals to 3y cubed. We just solve for the value of y in terms of x. And next thing is to apply our rule for this theorem of finding the derivatives. So by the use of the value of y, we need to input it here on our variable y. That's why it will look like 1 over 9 times the quantity cube root of 9x over 3 squared. Then perform, get the square root of those two, the numerator and denominator. So we have 1 over 9 times cube root of 9x squared, and then the square root of 3 is equals to 9. And next thing that we need to do, since we have 9 here and 9 here at the denominator, we can cancel this 2 and then get the square root of this inside of our numerator here, which is the cube root of 9x. And then the answer will be 1 over cube root of 81x squared. And from that, we need again to rationalize since we have radical in our denominator. So multiply the numerator and the denominator by cube root of 9x. And 1 times cube root of 9x is equals to cube root of 9x. Then cube root of 81x squared times cube root of 9x is cube root of 729x cubed. And then when we get the cube root of 729x cubed, the answer will be 9x. That's why in simplest form, we have the derivatives is equals to cube root of 9x over 9x. Now for our last theorem in finding the derivative of a function by the use of our radicals. So here, the derivative of your radical whose index is 2 is a fraction whose numerator is the denominator of the radicand and whose denominator is twice. The derivative of a radical whose index is 2, it means that when we have radical which is the square root like that because the index is 2, is a fraction whose numerator is the derivative of the radicand here, and whose denominator will be twice the given radical of the derivative exists. Let's see the example that we have here. Say I have the given f of x is equals to the square root of 2x squared plus 4x. Find f prime x, or the derivative. First thing is take a look at inside of the radical and then get the derivative of that. That's why we have d over dx. Quantity 2x squared plus 4x, because we need first to get the derivative for us to have the numerator, and then twice or multiplied by 2 the given radical. So we have 2 times the square root of 2x squared plus 4x. And when we get the derivative of this, we have this one. 2x squared, the derivative of 2x squared is 4x. The derivative of 4x is 4. We have here at the denominator, which is 2 square root of 2x squared plus 4x. And now get the common on our two terms from 4x plus 4. Then we can simplify it as 2 times the quantity 2x plus 2 all over 2 square root of 2x squared plus 4x. We need to cancel those two constant, or the number 2's here. And the answer for the derivative will be the quantity 2x plus 2 over the square root of 2x squared plus 4x. And this will be our answer. So that will be all for how to find derivative of the function, just make sure that you understand and make sure that you will be familiar on those different kinds of theories for our differential formulas so that it will be easier for you to get the derivative of a function, because sometimes we are applying multiple kind of rules to solve one given equation.